Assalamualaikum warahmatullahi wabarakatuh and a very good day, right? This is the first lecture video, asynchronous lecture video, which will try to conclude the topic of testing in this course, all right? Well, I'm sharing with you now the e-learning, all right? And we've gone through all the slides like this IEEE standard for PAS, HB, TT presentation. We've gone through them. And even before this, right? We've just finished this file, all right? There will be testings listed or established in IEEE standard form. And in here is the Electricity Supply Act, Electricity Supply Act Rules and Regulations, 1994. All right. Never mind. We'll keep this for later when we've done calibration. So for today, let's look at the incoming topics, which is like talking about the apparatus itself. All right. Referring to standard 4, right? We only deal with the required testings, but we don't have any idea on what the high voltage testings were done on. Were they done on transformers, switchgears, cables, and so on? So as you can look here in this chapter 6 is specifies on switchgears and cables, while chapter 7 is specifies on power transformers. Well, actually, why are switchgear and cables together and power transformers on its own chapter? Because power transformers have lots of tests, not only electrical tests, also mechanical tests included in their apparatus standard. And later we'll check on the apparatus standard. Okay, as you can see it, all right, for switchgear and cables, withstand tests, impulse tests, and PD. All right, but for transformers, you have induced over voltage tests, lightning impulse tests. So lightning impulse tests are also applicable on switchgear and cables, temperaturized tests, and even routine tests. All right. So therefore, it has its own special chapter. Well, over here is like the videos and for the assignment. All right, assignment is supposed to be a group assignment, but never mind. Let me think of it of how whether to conduct it as a group assignment or individual assignment. But just have a look at these videos because it will help you understand further on switchgear, cables, and transformers, and other apparatus such as disconnectors, surge arresters, and so on. Okay, have a look at this video. It explains to you the circuit breaker, power cables, all right, and power transformers. See, electromagnetic induction of power transformers and so on. All right, and also there's a video on power transformer testing. All right, okay. Then there's the instructions. Okay, for your group project, but you can have a look through. But I haven't decided to make it a group project or not for you. All right. But however, the related standards are here. Okay. And if you browse through, you see you have you have to download a file, standards SKEE 4613 assignment. And in this is a zip file. And if you open up the zip file, let me check whether you're viewing the same thing. Yes. There will be a there. Okay, you're not viewing the same thing, so hang on. There. So after pausing, these are these related standards that are available. And let's have a look at one. Let's see the yeah. Let one look at the ones below with the biggest file. And what is it? So it's a IEEE standard for common requirements for high voltage power switchgear rated above 1000 volts. So you have a switchgear above 1 kV, all right, which means a high voltage switchgear. You have a requirement here. I mean, you can establish the requirements for that switchgear. What does it have to do? Or what is required, and so on. Okay, hang on. Let me check whether you're having the same view with me. No. Okay, hang on. Okay, this is what I meant just now. Maybe just now I was just talking without the proper slide. So the slide is this one, which is the IEEE standard for common requirements for high voltage power switch gear rated above 1000 volts. All right. And if you can see here from the table of contents, all right, definitions, ratings, 1000 volts, what are the current ratings for that switch gear, all right, design and construction, also given the requirements, type test, okay, type test, the test you have to do during the design stage, routine test, production test, what are they? All right, see a lot of them. All right, for the type test, there are like around 7.2, 7.3. Before we go to section 8, they are like, never mind, let's open this one up. There. Dielectric test, radio influence voltage test, RIV test, measurements of the resistance of these circuits, temperature rise test, short time withstand current and peak withstand current test, verification of the degrees of the protection divided by the enclosures, all right, for the switch gear. Tightness test, this is mechanical. Electromagnetic compatibility test, this is EMC testing to see whether the switch gear will interfere with other electrical apparatus around it, or will other electrical apparatus around it interfere with the operations of the switchgear. So additional tests on the auxiliary and control circuits, X-ray procedure for vacuum interrupters. So vacuum switchgears, you have to do some X-ray radiation procedure. Number 8 is only the routine test. So this is during the design, while this is during the, hang on, yeah, when you manufacture, for each switchgear manufactured, you have to go dielectric test on the main circuit. Dielectric test means like withstand test is one of the dielectric tests. Dielectric test on the auxiliary control circuits. You have to do this withstand test again on the control circuits, on the auxiliary circuits, not on the switchgear itself. Measurement of the resistance of the main circuit, tightness test, design and visual check. So this is for the routine test, not as many as the type test, all right? And type test, the one related with our IEEE standard 4 is this dielectric test. Other than that, we have to refer to other than standard 4 because those are not high voltage tests. Okay, even though the apparatus is high voltage. So now you see, this is just for the switch gear. All right, hang on. Let me change another standard. So now I opened the file just below the file before, which deals with switchgear, and it is now for regulating transformers, not power transformer, regulating transformers. So, but still transformers. Look at the table of content, overview, general, resistance measurements, polarity and phase relations test, ratio test, no load losses, all right? So these are like in general, okay? Load losses, no load losses. Dielectric tests is the one which are concerned with standard 4. Then you have temperature rise test, short circuit test, audible sound emissions, calculated data, and therefore it completes the requirement for the standard test code. All right. Remember, this is not a basic requirement, but this is a standard test code for liquid immerse distribution, power, and regulating transformers. All right. So these are the tests given. So it didn't specifically say, oh, routine test is this, type test is this, but this is a standard test code. It depends on there's another standard that says, okay, this test is type test, this test is routine test, and so on, just like before. Okay, so do we have more? Yes, we do. Let's look at if there's any cables on that. Okay, hang on. Now we have cables. Look at the title. IEEE Guide for Field Test. There's one thing you need to know. Field test, not in laboratory, but at site. And evaluation of the insulation of shielded power cable system rated 5 kV and above. Look at the table of content, notice, introduction, contents, overview, normative references, definitions, safety awareness, general considerations for the field testing method is given, applicability of testing methods, and so on. So in the field testing methods, you can see there one of them is voltage withstand. All right, which means we have to bring the high voltage generation setup to the site and do the withstand test at site, not in the lab. Okay, so now it covers. I hope you understand what we meant by apparatus standard. All right, so let's pause for a while and we continue further with what is actually what are the insulations that we need to test in a transformer, in cables, and in switchgears, and maybe other apparatus such as surge arresters, which is involved, all right, in an electrical transmission and distribution system. Right, guys, let's continue. As you can see here, I'm opening Wikipedia on transformer. Very basic, from the very basic information about transformers until quite extensive and detailed information about power transformers, such as this one. Well, this is a good figure, right? Are you viewing the same thing as I am? Yes. Well, this figure shows you the cut out or cross-section area of a transformer. Okay, this is the bushing. And as you can see, the bushing is large, which means the insulation is also high. So this is high voltage terminals, 1, 2, 3. The low voltage terminals are back there. You can't really see it, okay? Size is small. So however, these high voltage terminals are connected to the high voltage coils, right? And within these high voltage coils are the lower voltage coils, and their terminals goes up to the lower voltage bushings. Everything here, okay. There you can see a orange color, but actually it is paper. All right, paper when immersed with oil, it becomes sort of like this color. If I can zoom in further, oh, that's the best I can zoom. Oh yeah, this is the best I can zoom in further. And these are windings, all right. And all these these windings are insulated by paper, so that windings and windings don't short circuit each other. Between phase 1, phase 2, phase 3, or maybe phase red, yellow, or blue, okay, A, B, C, red, yellow, blue, or whatever, doesn't matter as long as it's 3 phases. This is the nameplate. Okay, as you can see there, all the details about this product is on the nameplate. And as you can see, this very awkward looking fins, all right, they are actually the body or the enclosure of the transformer, and everything inside here is filled up with transformer oil. And this transformer oil, when it goes to the fins, it becomes cooler because it can distribute the heat from the oil itself to the environment. So it becomes cooler, and then it goes back to the center of the transformer. So this is a cooling system, and they call this cooling fins. And everything else is made of metal. Here are the lugs, so that you can lift the transformer using cranes. And over here is the storage for the extra oil. If there is a leaking here and the oil reduces, you have some storage here. All right. But if even the storage is empty, and then we don't want this part to be empty, because if this part is not without oil, then you have air. When you have air, the insulation is much poor. So you will have breakdown inside the transformer. Okay, clear? Okay, hang on. Okay, let's continue, but still with transformer. Okay, cooling, insulation. All right, here. This is a substation transformer. Well, still the figure is about, you can only see the fins there. Okay, the cooling fins. Right, but it is bigger because, as you can see, there's a figure of a man there, sort of doing the connections before the testing. Okay, right. Next, the insulation, meaning the oil, the paper, and so on. The bushings, The bushings, like I showed you before, these are bushings. They call these bushings, where you put some ceramic between the conductor and the body of the transformer. Okay, application. So this is a sort of a cutout of a transformer. Okay, you can see here oil everywhere. And then the windings, you have paper. So paper and oil. But if the oil is depleting or leaking over here, then the oil level will become less. Even with the reserve tank oil also we cannot support. So there will be pockets of air here that will reduce the insulation by a lot, and surely breakdown will occur. We won't like that situation. Okay. And if you look further, it's about induction coils and no more about testing. All right, so let's pause for a while and change from transformer to switch. Now, switch gear at Wikipedia. All right, even here, these are all switch gears. All right, this one as well. This is where they switch off or switch on inside this thing. Okay, it is a switch gear inside. Right. And what else? Figures. But the main switch is there, but the controlling of the switch is usually indoors and from a panel like this. So this with a combination of this one is called a switch gear. All right. And if you look further, let's look at figures. Okay, you should take your own time and look at this Wikipedia uh, article because it helps a lot. This is a tram switchgear. Tram because it is like continuous. Okay, tram. I hope you understand the meaning of tram. While this is a circuit breaker, which also switchgear, but it uses sulfur hexafluoride, which means it can be more compact because the insulation is using that gas, not oil. Because if it's using oil, then it would need a bigger space to have the same amount of insulation, or not even air, because if it's air, then it would be needing a much larger space. So SF6 is here, it will be compact, and whenever there is switching occurring, that SF6 will try to quench the arc that occurs. So that's why they use the SF6. All right, switch gear. All right, early switch gear during the 1900s. Let's have a look there. All right, the purpose is the same: switch on and switch off safely, regulated. Okay, that's the idea of a switch gear. Switch on and switch off, be sacred, safely and regulated. And if this is an oil filled high voltage circuit breaker, which is a switch gear, but more on towards where the switching is occurring, and it occurs here. All right, the switching occurs here. You have springs, all right, to make sure that when it switches on, it is complete contact. When it switches off, completely not in contact. All right, and inside here is filled up with oil so that when sparks occur, the oil will quench or make sure that the explosion of the spark doesn't damage the circuit breaker and also the compartment itself. All right, the whole thing. So this is the actual thing you see. This is you cut it out. All right, inside. Nice switch gear. So the insulation can be, as you can see here, oil, air, gas, which is SF6. What else? Hybrid, a mixture, vacuum, nothing within. So you expect arcs to be not that big when there's no oxygen, right? Carbon dioxide, this is like insulating as well. Protective circuitry, circuit breaker and fuses. So that's why it's called a switch gear. It has a circuit breaker, it has fuses, it has control circuits, it has distance relays, and so on. All right, and so this is 245 kV circuit breaker. in action. It's not in action, but I've given you the disconnector in action, right? From a video last time. Okay. And this is a 245 kV, but very big in size. 420 kV, higher voltages, but smaller in size because it's a gas insulated switchgear. So this is a person. This is a gas insulated switchgear. This, you cannot see a person here, but basically a person is quite small. And this is just a 275 kV air insulated switchgear. Okay. Nice. So I hope you understand the meaning of, or the switch gear itself. All right. Where is it used? Even in our campus, we have switch gears at the uh new campus area where the voltage coming in is 132 kV, being stepped down to 22 kV, and they have transformers over there. Whenever you have transformers, you step down the voltage, you will need to have switch gears, and all of them are controlled by SCADA. What is SCADA? I hope you still remember what SCADA is from power systems. Supervisory, control, and data. I forgot the last sentence for that. Acquisition and data acquisition. So supervisory, control, and data acquisition. So that's what SCADA is, to help you control the power system. Right. Next is cables. Hang on. Well, yes, what you are seeing here are cables. And let me choose this one. High voltage cable, and in particular underground cable. You have seen this physically yourself, right? I brought this into class. And this is a single phase. Both of them are single phase. Usually the outer layer have a metal part as well, but that is more for the mechanical strength. Here, mechanical strength. In terms of electrical property, these outside layers are semiconductive. All right. Why should it be semiconductive? Because if it is not semiconductive, charges will start to occupy the surface. And when you have charges occupying the surface, you are talking about uh, build up voltages on the top of on the outside of the circumference of the cable. And whenever, if it's fitted underground, and somehow if you have access to it, if it's not using semiconductive uh, insulation here, then they will build up voltage, and it will be dangerous for us to handle the insulated part of the cable. All right, because charges are building up there. Okay. So looks simple, cable. All right. So the insulation, XLPE, right? Okay. Insulation is XLPE. You have single phase. You also have three phase. More than three phase also you have. Here is a three phase conductor. There, 1, 2, 3. So the insulation between phases have to be tested. The insulation of the phases to the ground outside also have to be tested. Okay. There. This is a 69 kV medium pressure oil filled cable. See, the cable is filled with oil, and usually this is for the undersea cables. Okay, undersea cables, not only underground but undersea. All this while we are having power being delivered across oceans, but we also have data being delivered across oceans. All right, and they are using this type of cables for power, and another different type of cables for data. Sometimes they use optical cable as well. Okay, cable terminals. So very basic cables, and it doesn't here uh, show about test or whatever. But let's say we try to search high voltage cable testing. No need. We need to do that. No need, because it's better for us to refer to this apparatus standards that is applicable. All right. But if you search in wiki, well, you will have some general information. So let me do it. Hang on. So guys, all right, maybe you are seeing me browsing. Okay, never mind. So I hope we are viewing at the same page. Yeah. Oh yes, yes. Okay. VLF cable testing. So what I did, I typed cable, high voltage cable testing, and this one of them results coming out is VLF cable testing, very low frequency withstand testing. Okay. All right, and then it also includes what standards to be used, because this is not high voltage testing. All right, this is VLF withstand testing, VLF 10 delta testing, very low frequency partial discharge testing. And it is this very low frequency partial discharge testing it are being used widely now as a diagnostic tool to determine whether the cable is in good health or not, and it can be done during the cable is energized. All right, so hang on, let's check out the standards further. All right, well, one of the standards given in your e-learning apparatus standard is the guide for transformer impulse test, right? So this guide, which is, let's look at the number. What number is it? IEEE standard C57.98, 2011. Okay, is specifically transformer impulse test. All right, and look at the table of content. Impulse testing, general. Impulse wave shapes should be either switching or lightning there. Lightning impulse test circuit. Switching impulse testing. Grounding practices. Impulse generator size. So you have more information on specifically impulse testing on transformer from this standard alone. So that's why the apparatus standards must be used with IEEE standard 4. All right, because IEEE standard 4 is specific in general about high voltage testing, but apparatus standards gives you actually all the necessary testing for a particular apparatus. And further, it does not involve only electrical or high voltage testing. It also involves mechanical testing, tightness, fittings, sometimes even ingress protection. All right, because most of these items will be operating outdoors. All right. So with that, I believe I would stop this video first, because as usual, we cannot take it won't be effective looking at the video more than half an hour, because when we view the video, you are able to stop and further look for more information and then continue. So a 30-minute video might take more than 1 hour for you to view. All right, so let me stop this first video first, then I continue with the coming videos in the coming near future. But don't worry about the tests, because somehow the mid-semester break is occurring next week, so for sure no test, and I need to get the test being vetted, and after the test has been vetted, let's think about when to conduct the test. But for the moment, have it as it is. We'll be having lecture videos, and I will inform from time to time of the if there is any coming videos that has been published. I will inform through WhatsApp and also in the e-learning. So for the moment, just stop here, because 30 minutes is good enough for the first video. All right. Thank you very much. I'll see you in the second video, or maybe the third video in the future. With that, I hope you have a good day and all the best. Assalamualaikum warahmatullahi wabarakatuh. If it's nighttime, good night. Bye-bye.